Hi folks, so today we're going to do the skills checkpoint translations and reflections homework. And what I'm going to encourage you to do is just pause the video and go ahead and plot all of the points that you see. I'm going to do the same so the video will be a lot shorter. Okay, so the first thing you want to make certain of is that your own name is in the top right corner, right? So that's me. Okay, and I tell you what I'm going to do is I'm going to do the left-hand side of the page. So I'll do all the odd numbers, and then I'll expect that you guys can do the even-numbered questions, okay? So this just says, in words, translations, a translation, 3 units right and 4 units up. So when you count, you don't start 1 right here. You actually have to go over 1 before you say the number 1. So 1, 2, 3. There should be 3 red dots before you get to 3. Okay, so 1, 2, 3, and then 1, 2, 3, 4. Now notice that I have to go up 4, so those are my 4 red dots right there. Okay, so 3 units to the right, 4 units up. So that's where I'm going to put my new point. And I'm going to do the same with every corner, and then I'll just draw the figure. So 3, 4, 3, and 4. Okay, so I went 3 right, 4 up on all 3 of those. Then I'm just going to connect those with a nice straight line with my straight edge. It's nice to have a little straight edge like this. If you guys have a license or a library card, use that. So number 3 says almost the same thing. Let me see. It says translation, but it says translation and then it has this mathematical notation. Okay, so we've been working with that mathematical notation. So let's see what it says to do. It says turn every x into x. Well, if you're turning x into x, then don't move it right or left. So don't move right or left. Okay, if you're turning x into x, then it's just going to stay exactly where it is. Now, it does say, though, that we need to take y and turn it into y plus 2. So that means that every y coordinate on this picture needs to be up 2. So we're actually going to move the figure up 2 units. All right, so 1, 2, 1, 2, 1, 2. And that last one's a little bit odd because it lands on the original pre-image. So, but don't let that one throw you off. Okay, so here we have a quadrilateral this time. And with this quadrilateral, we are going to reflect. Okay, so the last 2 problems we were doing translations. On this one, we're going to be doing a reflection. So to stay consistent with my previous videos, I'm going to use my reflection line to be this turquoise colored line. All right, so that's your y-axis. And remember, the y-axis is the same equation as x equals 0. Okay, so all we need to do then is just make a mirror image over here on the right side. But we have to be exact with it. So we're going to make a mirror image. So this is 4 units to the left of the axis, so we need to go 4 units to the right. This is 5 units left, so 5 units right. That's 2 units left, so 2 units right. And this is 4 units left, so I need to go 4 units right. Now, that is basically how I would do the reflections. However, what if you weren't given a picture? Okay, if you weren't given a picture, there's still a very nice way to look at this. So let's say there was no graph given and all I said was these points. What happens to all of the x coordinates if you reflect across the y-axis? Well, all of those x coordinates, all we do is change the signs. Okay, so basically just change the signs of the x coordinates. So that's a quick shortcut. So in other words, if I had -5, 0 as my pre-image, then my image would just be 5, 0. I changed the symbol of the x-coordinate. Okay, so I want you guys to decide what you would do if you were reflecting across the x-axis, and also think about if we didn't have a picture, what would happen to all of these. Onwards. Okay, so number 7. It also looks like a quadrilateral, but it's actually a special kind of quadrilateral. Extra money to the folks that know that one. That's called a parallelogram. Okay, both pairs of opposite sides are parallel. So anyway, it says that we're going to do a reflection across y equals 1. So there's a little bit of math notation here. Y equals 1. Well, I know that the x-axis is at y equals 0. So this is y equals -1 and y equals -2. So y equals 1 better be right there. And y equals 1 is still right here, right? So actually, the line y equals 1 is going to be a horizontal line. So anytime it's y equals some constant, it's going to be horizontal. Okay? So that's that. And now we just need to reflect. So I'm 1 unit away from it, so keep it 1 unit away from it, just on the opposite side. Now these up here at the top are 4 units away from the blue line. So I need to go 4 units down from the blue line. And again, 4 units down. And then what we'll do is we'll connect those with nice straight lines. So grab your library card, index card, driver's license if you're old enough, right? And anyway, that one kind of reflects on top of itself. I think that one's pretty neat to look at. On the next one, it says there's a reflection on x equals -1, and hopefully you can see that it's x equals a constant, so it's not y equals a constant, so that line's probably going to be a vertical line then, okay? An up and down line. All right, so numbers 9 through 12 ask us to turn into mathematicians and write this, and instead of saying the verbal description, it says to write a rule. All right, and this rule, we want it to be in math notation. Okay, mathematical notation. Sorry about being off the screen there. All right, so now I need to go, let's see, h goes to h prime. It looks like it goes down 2 units, down 2 units, and down 2 units. So you can kind of hear me saying the words down 2 units, but I need to turn that into mathematical notation. So I need to convert every xy into, well, nothing happened to x. I didn't move it right or left, so x is going to stay the same. Now every y value I move down to, and the way you move down to is you subtract 2. All right, see what you can do with number 10 then. And then we'll look at 11. So looking at number 11, it no longer looks like a transformation. I'm sorry, I said the wrong word. It no longer looks like a translation. It looks like a reflection. More than that, it looks like a reflection on the line x equals -4, and I knew it was x equals because it was an up and down line. It was a vertical line. Okay, so in words, we would just say something like reflection over, or you can say reflection on x equals -4. All right, so what have I taught you today? I taught you how to answer a few questions dealing with translations and reflections. So if you can do the right side of the page and then double check with a partner You can call a friend. You can email me a picture of it if you like, and I'll give you some feedback. Thanks a lot, guys.